Hello, everyone, and welcome to today's webinar. So today we'll be discussing the results of a survey that Instrumental ran over the course of the past few months, the 2021 State of New Product Introduction. And we'll go ahead and get started now. Let me introduce our speakers, Anna Katrina Shedletsky and Tobias Harrison Noonan. I'll let them give a brief 30-second spiel on their backgrounds.
Hi, my name is Anna. I'm CEO and one of the founders of Instrumental. I'm a mechanical engineer by background. I spent 6 years growing up as an engineer at Apple, and then started Instrumental almost 6 years ago. And we're focused on enabling companies to find and fix issues quickly in their development and production processes with technology and data.
Thanks, Anna. So I'm Tobias, also mechanical engineering background. Spent about 6 years doing product design back at Apple. And I'm here at Instrumental now, leading a team of mechanical engineers to deliver our technology to our wide variety of customers.
So I'll give a brief update on the methodology of this survey. My name is Joel Garcia, the head of demand gen here at Instrumental. And we ran the survey as part of our Build Better event, which occurred in February. We surveyed attendees and we ran a few promotions to customers, as well as to others in our space, leveraging different partner relationships throughout October until February. And we asked people to consider their experiences with NPI over the past 12 to 18 months, with the exception of a few specific questions where we asked them to consider the past 5 years of their experiences. The audience seniority of those who responded ranged from C-suite to VPs, to mechanical engineers and other individual contributors. That's what the 30% breakdown in other is. And their functions ranged from engineering to operations and to quality assurance, with some automation, process engineering, and other peppered in. We were able to collect data from over 100 different organizations who were across the spectrum, from consumer electronics to medical devices, energy and batteries, and more.
Yeah, so I think the kind of core piece of the motivation for this study was just that we operate in a really large market. It's growing to over $1 trillion, just the consumer electronics vertical of it. If you include electronics more broadly, this could be as large as 3 trillion or more, depending on which resource you look at. And one of the things that's really mind-blowing and has been mind-blowing to me about this space is there's really not a lot of process innovation going on. There's not a lot of dev tools for engineers in this space. On the software side, they get all the toys to make their jobs more efficient and able to do more with less. But there's not a lot of investment in that on the hardware side. And so we wanted to learn more about that and how companies are kind of interacting with the challenges that 2020 threw at them and kind of how they're thinking about moving forward. So leaders of NPI programs are really juggling a bunch of competing priorities, and they're always working on trying to get the business outcomes and the core KPIs that they've signed up for. Those priorities evolve over time as the market changes, and there's kind of key drivers of competitiveness and speed to market and fundamental innovation that they're trying to balance. And so essentially what we asked our survey respondents was to understand what the kind of top 3 priorities that leaders were focused on, particularly for programs. And what we saw is that launching on time is by far the most significant and most shared amongst NPI folks as the top goal of achievement. So that on-time delivery. We then found that kind of the second and third were kind of tied at the cost target, as well as meeting the feature goals like the marketing requirements or product requirements for a particular product, which are certainly very challenging. We've included some of the other ones here just because people might be interested around specific yields or UPH or things that could be more production focused. But ultimately, I think the core takeaway here is that launching on time is the most important goal that most NPI leadership is focused on. And so if 77% of NPI leaders agree that shipping on time is the most important goal, and recently as part of this study, we also found that 43% of new electronics products have actually shipped late over the past 5 years. This is pre-COVID data. So this is before there was that kind of funky year that caused a lot of delays. Why is that? Why is that happening?
The 43%, that's actually a really interesting number. You know, coming from my background at Apple, schedules were always a very contentious topic. We would always start out with extremely aggressive schedule targets, but we didn't really have a plan about how we were going to compress the schedule more. Every year, we were trying to cut out days or weeks on the schedule. And I think, again, talking with a lot of our customers, many of them feel that they're seeing these same schedule delays, but it's really interesting to see that 43%, that's a pretty massive number amongst the whole industry.
I'll add a little bit of context here, which is according to a different survey from EPS, which is available on EPS News, 53% of NPIs were canceled or delayed last year, which isn't too big of a jump from the 43% that we asked as part of this survey. So it's clear that something has been broken with the NPI process for a while now. We can't just lay all the blame at the feet of the pandemic. There's been an issue with shipping products on time for a while now. And so moving forward, Tobias, I don't know if you want to jump in here.
Yeah, I can mention a few. I think these leaders are they're juggling many different factors that are threatening to hit their NPI targets for this year. You'll see a lot of these like these supply chain and these travel restrictions. A lot of these are not directly in our control. And what we really want to focus on is which of these, as leaders, can we actually control and make like tangible improvements on going forward this year. And so this engineering bandwidth up at number 2. Go ahead, Joel.
Well, the thing to note here is that the biggest threat to an NPI program is the disruption to the supply chain, which is completely out of your control. But there are a few specific things that are within your control, as you mentioned.
But yeah, I think the kind of core point here is that in that ranking of things that that are threats to NPI schedules, these top 3 things, these specific 3, which make up a significant portion, are actually things that there is a lot of control over, that leaders can actually fundamentally make changes around. So how they think about bandwidth or headcount, how thinking about travel and maybe ways to get around travel. I think travel has always been a band-aid in the first place. And so that is something that there is actually something you can control about, why we travel, what we do when we travel. And these build schedules that are very aggressive. I think just even the survey was maybe a little leading by using the word aggressive on the build schedules, but it's something that we hear a lot about, that the schedules are often overly optimistic, and so they're often late because of that. So in the past 12 months, the number of people on NPI teams has actually decreased or stayed the same. And so even though there's this expectation of products getting more complex and the schedules are very aggressive and like, oh, by the way, there's a global pandemic, so like we're going to tie a hand behind your back so you can't use the normal tools you use, the teams are the same or actually getting smaller. And so this is very interesting kind of combination that we're asking teams to do way more, but not necessarily putting more people on those problems. And the results aren't there. It's not like we're just getting more efficient and we don't need those people, because 43% of those programs are still getting delayed prior to COVID. And then in COVID, Supply Frame and Dimensional Research did a study that said that 53% of programs were delayed or canceled.
All right, so going a layer deeper here, we're looking at what in a given week these engineering teams are actually spending their time on. And when we surveyed here, you can see the core design work and innovation, it actually comes out to a surprisingly small chunk, just 23%. And all of these other buckets on collecting data, communicating status updates, analyzing data, all of these add up to a very significant chunk. So when we add up all of these together, we get 77% of these engineering teams' time are being spent on non-engineering tasks. These tasks have a huge opportunity to be either automated or at the very least expedited with better data. And personally looking at these numbers, I had always anecdotally had a sense that there's a lot of overhead for this design work. I've heard it from many others as well, but it's really interesting to see, even amongst such a wide audience that we surveyed, to actually put concrete numbers to all of these different inefficiencies on top of some of the core design work, and putting some financial numbers on this inefficiency. So if we take 20,000 NPIs per year, 10 engineers per program, with an estimated fully loaded engineer cost, and the 77% productivity loss. This is a $26 billion problem. And again, this is just the time efficiency loss. This isn't taking into account any of the other consequences of this inefficiency. So this is a big, I would say, inefficiency and opportunity. And yeah, speaking of other consequences, let's talk about the team. So 71% of the engineers responded that they are frequently working nights or weekends. So this is a huge number, and at least from my experience, the work that you're doing on nights and weekends isn't necessarily the core engineering work that you probably enjoy. I don't know, Anna, from your experience. It's normally.
Gotta love those Friday night build kickoff calls to get the build going for Saturday morning in China.
Yeah, and this extended overtime of firefighting, it can lead to team burnout. And so as leaders, we have to consider this as another consequence. We've identified the team as our most valuable resource. And here we've identified a risk of maintaining that resource over time because of some of these inefficiencies. And we also surveyed on which tools these engineering teams are using. And so, not surprising, up at the top, we have spreadsheets and CAD tools. I'm actually surprised the spreadsheet isn't all the way at 100%. I'm pretty sure everyone is using spreadsheets at some point during their engineering. Another interesting data point that we found, cloud-based data storage is actually up at 42% now, which is a pretty significant jump from, I think it was a couple of years ago, we had some data that was only 10%. So this is a big move in the past couple of years, and I think is a move in the right direction towards automating some of these inefficiencies. And another, the AI-based defect detection, this one still pretty early on. So just at 11%, this one, I think there's more opportunity for this to grow, and again, start to tackle some of those inefficiencies that we saw in the work week previously.
So I think one of the kind of core things that I was really interested in from these results is really understanding whether engineers felt empowered to actually solve problems and have influence on, launching on time and building a great product, or whether they feel pretty powerless in it. And so I think one of the kind of things that really struck me about this research was just that essentially the most or half of engineers feel pretty powerless. They don't have the data they need to do the job that they want to do. And often don't feel in a situation where they could fundamentally change the factors that dictate how they work. And so if you add that up to the burnout of working on spending a significant portion of your time on the part of the job that like doesn't bring you joy, is probably adds up to, morale hits and folks leaving this role. And we certainly have, I know both Tobias and I have anecdotes, and technically like in ourselves, in our role here at Instrumental, have, although we are investing to hopefully solve these problems, have left the role of this firefighting as a result of just not feeling empowered to fundamentally change how we work. And so I think as leaders, this is a wake-up call that there are opportunities to invest in efficiency and productivity gains, particularly during NPI. Just because we've done it a certain way for the last 2 decades doesn't mean that's the best or the right way to do it now in a fundamentally different world with fundamentally different tools. I bet there's this other kind of interesting takeaway where we actually asked respondents to share a little bit about their relationships with their contract manufacturers, JDMs, or manufacturing partners. Here we're using CM as a catch-all for all of those types of partners. And this is something that, anecdotally, we hear some people tell us like, oh, we trust our factory. Others tell us like, oh, we don't trust anything from the factory. And so it's really interesting to actually get some real data about those working relationships. And it was really great to see that most respondents really feel like they have good working relationships with their CMs and that they're able to communicate effectively together. However, it was a little bit disconcerting to see that there's a lower amount of trust in those relationships, and ultimately, specifically around surfacing issues quickly. Mostly this can come from, good intentions, perhaps on the side of the CM to try to handle issues themselves and maybe not surface things right away. But it makes it really difficult for teams to be most effective together if like half of your team isn't telling the other half what problems there are. And so this is kind of a core piece that, it sounds like there's a great opportunity to improve these relationships and improve the speed at which problem solving can happen when working with manufacturing partners. And then as another question that we asked, and frankly, the last question was really around optimization and the maturity of someone's optimization process. So just as kind of a refresher for those who are less familiar with this concept, optimization is really the whole process of continuous improvement, but instead of on the 1-by-1 unit level of failure analysis, it's at a population scale. How are you shifting and tightening the performance of a population of units? And so I think in terms of optimization and how that has been adopted by the electronics manufacturing industry, it's generally on the lower side. And this is kind of a new thing, that there's opportunities that maybe we could actually do optimization faster in a way that would fit into how we work in electronics manufacturing. And so it was interesting to see that most organizations recognize that they're not really advanced in optimization technologies. They're not using them or adopting them as fast as they would like. And that includes things that would fall into the kind of larger buckets of smart manufacturing systems. It includes automation and other continuous improvement techniques. And I think we all know as engineers that these are things that like we should probably be doing more of. But I think at least me, like my commentary on this result is I think this means that they haven't been well adapted to the ways in which we fundamentally work in electronics manufacturing. And so that because the cycles are faster, things are run for shorter periods of time. End of life it happens way sooner than in other types of manufacturing where many of these optimization methods were developed. It just means we haven't really found the right fit in the market yet in terms of how we can optimize as a market. However, we are seeing continued interest in how companies can start to apply these principles of optimization from other manufacturing verticals into electronics manufacturing, particularly as data and technology tools have made them more adaptable and more appropriate for those fast, rapid cycles that exist in our market that don't necessarily exist in the others. And so one of the things we did as part of the survey is we asked leaders what they're doing for NPIs in 2021. They had this crazy year in 2020. They had to adapt. They didn't plan on it, but in 2021, they actually had time to plan. And so what are they planning on? Here we're showing the full list of results, but the top 3 are really around trying to make efforts to improve engineering efficiency. And so this is things that are enabling teams to work faster. This is probably technologies. This is probably rethinking how their engineering teams work. Some are exploring new suppliers or CMs in new regions. Some are actually putting remote team members into countries or near where those suppliers are. And a third place was investing in implementing new remote monitoring technologies. So I think people are realizing that Zoom is not the way to build a new product. It can be useful for a meeting and for face-to-face, but it's really difficult to do failure analysis and actual engineering work over Zoom. And so there are a bunch of investment in cloud-based and other kind of remote monitoring technologies that help to get that data from the line to your engineers wherever they are. And so kind of 4 buckets of specific things that leaders shared, and you can actually read some of the details here, and there'll be more details in the full report that we will release later today. But there's 4 kind of core buckets that leaders are making for 2021. One, they're focused on kind of better remote collaboration, more tools to help them do that. That might be Slacks or Jiras or other types of technologies that are just helping to get that communication flowing. There is a bucket of enhanced data management. So actually trying to do a better job of communicating all of the data and information, and also the problems that are being tackled and what the resultant KPIs are once those have been tackled. There is a whole bucket around building better relationships with suppliers and partners. And so some have actually moved more towards a JDM model this year, where they've handed off CAD to the CM. Others have hired local team members that are in the CM area, so they could actually physically be in the factory. There's a big rush on talent for that over the last year. And then the last bucket is really around internal resource management and actually focusing on the operational aspects of actually doing NPI. One of the interesting trends in software companies is this whole idea that there's an operations person for almost every function. So sales operations, product operations. And I think what we're starting to see is that there's also kind of an understanding that there's an operational element to every function and role, and equivalently so there's an operational function to how you do NPI itself and the process of NPI, more so than just the operations of the line that goes along with NPI. And so that's been very interesting to see that kind of evolve as an area of focus for leaders. Alrighty, want to share a little bit about Instrumental and kind of how we're working to turn firefighters into engineers, spend less time doing things that is not engineering and is mostly firefighting or data cleaning, and actually turning them into engineers. And so what we do is that we help to accelerate your engineers so they spend less time trying to figure out where the problems are, and actually more time solving those problems, doing failure analysis and getting corrective action, and helping all the teams communicate better with each other as they do that. So as kind of a quick introduction, and this will be very quick, to Instrumental. So what we do is we really fundamentally believe that the key to better products is really locked in silos throughout your supply chain, not just at final assembly, but also upstream. Measurements that you might be taking, functional test data you might be gathering, generally lives locally on all these kind of siloed stations, or maybe in FTPs, each supplier with their own system. So next slide, please. So what Instrumental does is we aggregate product data across this supply chain. So all those measurements and functional test data can be used to create a complete digital thread of your product tied by serial number. And then what we do with that is we enhance it and enrich it with images of key states of assembly of every major component or subcomponent. So if you have upstream elements, like in this particular example, this is a 3-dimensional camera. If you have an upstream camera vendor, there could be interesting and useful data from that camera vendor that can help you downstream. And so we gather those images either from your existing AOI cameras or we have drop-in systems. As a result, it enables you to actually identify that when there's an issue downstream with the camera, you can immediately tell and pinpoint where that came from in your supply chain. And so that whole failure analysis process can be accelerated significantly, which is one of the key points that engineers are spending a lot of time doing failure analysis, or even just getting the data and the communication in the first place. And this lets them actually identify and pinpoint not just that there is a problem, but where the solution may be in minutes. So this is a significant acceleration on that. And it helps to streamline communication between your downstream supplier and your upstream supplier. And so what we do then is we have AI that's really analyzing the terabytes of data that's being collected, because it's so much data. Like, your engineers don't have time. They're already getting way too many reports and things that they're probably not looking at. They don't have time to look at the raw data. They need something to tell them what's important. And so that's the AI that we've built, so that we look at the data so that your team doesn't have to. One of the core kind of things that we've done this year, new features that we've built this year, is particularly in tying together functional test data to the images. And so what that means is, if you have functional failures downstream, we can actually now have AI that helps to identify the potential root causes associated with those failures. So what is causing those antenna failures? Is it because the antenna element is shifted? That's the kind of root cause that we've been able to find for customers automatically, leveraging this AI technology. And so, as a summary on the next slide, we have kind of the kind of core pieces that what AI is doing to do the heavy lifting. One, we're finding issues earlier by looking everywhere on behalf of customer engineers, so they can just consume where the anomalies have been found and identify if those are real issues. We help them to accelerate failure analysis. So once they find an issue, they can find out how many more there are, and quickly understand if it's systemic or a onesie-twosie kind of failure. And then we are also now suggesting root causes for functional failures. And then, as a kind of last piece here, one of the core pieces is we think about the complexities of bringing a product to market, particularly all the communication that has to happen, that's taking up a significant portion of that engineering time in NPI, is really about getting the right data in front of the right people in as close to real time as possible. And so Instrumental is built in such a way that everybody in each of their roles is supported with the data that they need to make decisions. So, executives are able to understand the risks of programs and get kind of dashboards that let them do that. Product design engineers and mechanical engineers are able to consume the failure analysis and correlations results of what root causes might be. Quality engineers can understand the full stack of Pareto, so they know what to focus on and can prioritize. We also have live quality alerts. And then, of course, the table stakes for any type of system that operates on the line is you need some real-time response for the operator to be able to take an action. And so, of course, we still provide live intercepts on the line to actually catch issues as they happen. And so we'd love to actually demonstrate a new feature that we have recently released that talks about how we can actually automatically identify root causes for our customers. So I'll let Tobias do that.
Thank you, Anna. Yeah, I'm excited to show you guys this Discover Relationships feature that Anna mentioned. Again, this is all about automating the failure analysis process. And again, looking back at where engineers are spending their time and our previous experience, failure analysis is a key portion of these product design engineers. That is what a significant portion of their time goes into, is solving these issues. So I'm going to show you just a quick demonstration. So here I'm logged into the Instrumental platform. Again, all my units on the right, and all of the data that we've aggregated, including images and functional tests, down at the bottom. And common scenario, like Anna alluded to, is I may have a functional failure, let's say antenna failures that I get notified about. And the typical failure analysis process, I would jump into probably communicating with the factory, getting data, teardowns, images, a multi-week failure analysis process for some of these complex failures. And what we're automating here is I can jump straight to my antenna data, and I can easily get some quick context. So here I can see that, oh, yep, it looks like my Bluetooth antenna test has some failures. I'm just going to hop in there. And here I'm going to look at just these gross failures. So here I'm highlighting 8 units that failed this antenna test. And what the AI is doing is it's automatically looking through all the images of all my units, and it's identifying a potential root cause for me. So you can see here, this is very likely related. It's identifying what looks like a grounding tab. So again, this would be critical to antenna performance, and it's finding a series of units with missing or bent grounding tabs. So just like that, it's automatically done this root cause analysis, this full multi-week process for me in just a few minutes. And again, that's just the start of it. I could take it a little further if I want to look at the marginal failing units. And again, here it's finding a correlation for me. This looks like contamination on a grounding tab, which again is likely contributing to some of this antenna performance. So this, I'm just really excited about this feature because it's such a long process that it's doing automatically for us. I think we've seen already that there's pretty large time savings to be had here. So that's just the start. Excited to show anyone, some more in-depth features in the future as well.
Yeah, I think just to add like a little bit more on that one, we keep kind of using an antenna example because it's one of the examples that our actual customers have found to be really impactful. We had a customer who, as many of you know, like antennas and small electronic devices, generally you have like these micro coax feeds. And we had a customer who had these kind of mysterious antenna failures, and they were able to use Discover to actually identify that the ones that had a weird performance had like exited the coax, like the cable like kind of was going at like 10 o'clock instead of at noon. And just that amount of like angle made a difference that they could see, and there was a very strong correlation for that. So they were able to go try to figure out like what that was about. And it was the kind of defect that if you were looking, and even if you're a trained engineer and you were looking at like the wire leaving at 10 o'clock, like there's enough service loop for that, that should be okay. You might not have identified that that was a failure until you saw that like, oh, all the ones that are failing go out at 10 o'clock and all the ones that are passing don't do that. It then gives you an indication of something that's like maybe not subtle to dig into. So it's been very interesting to see our customers apply Discover relationships into their real builds and save a lot of time.
If anyone has any questions, please feel free to add them to the chat. Otherwise, we can end early.
I see some excitement in the chat about Discover relationships, which is great.
Yeah, just to panelists. Thanks, Kevin.
All right. Well, thank you so much for your time. I think it's going to be a great weekend for everyone. So I hope everyone gets a chance to. Oh, we do have a question from Kevin, actually. What is the plan to continue evolving 3D inspection in a small space?
That's a great one. And we have gotten a few requests from customers on essentially expanding our data collection capability into things like 3D, X-ray are probably the most common ones. 3D, the plan is we're working with a few partners actually on integrating into other data sources. And we would love to have a 3D imaging partner. There's a few that we are aware of. And so our end goal, and Anna, if you want to jump in, our end goal is to, again, have the instrumental platform be capable of taking in these different image sources and then partnering with other hardware partners to bring this data to our customers.
Yeah, so if you have a data set, let's chat. Let us know, and we'll be happy to work with you. I think that's definitely aligned with kind of core strategic move that we're making, and we have some exciting stuff in the works involving these other types of data sources that we'll be announcing soon.
Yeah.
There's another question from Patrice about with today's supply chain difficulties, how does your AI account for new parts used as substitutes? I think this is a great question, and actually has come up before, because if what our AI is doing is finding anomalies, how can it differentiate between intended anomalies like substitutes versus anomalies that are actually defects? And the way that I would describe how the AI works is we identify anomalies, and so things that are different, and we do so, and we do so in a stack rank. So there's a whole group of kind of, we call them discoveries that have been found, and our customers are able to then quickly look through those discoveries and identify things that are interesting or not interesting. So it is possible that our AI will discover that there is a substitute part in that position, but you can just then quickly describe that as not interesting, and it will stop. It will learn over time to take those results out of your discoveries. But it's an important thing for us to do, because in some cases we've had customers actually find that the wrong part was stuffed in a particular location that they did not intend, and that can be very helpful. So we don't, our AI is not making judgments at that level. We're still relying on the expertise of users to tell us what's interesting, and to enable our AI to get better and better at finding things that are true anomalies and true defects.
Another thing to add on there too is our system also has capability to segment out data. So if you know you're getting a new configuration with a new part, we could intentionally put that into a different configuration. And because our AI is pretty flexible and we only need 30 units to set up, we could actually process these configurations independently, since you know there's going to be something different. So that's kind of a unique advantage of our system being able to learn so quickly.
Well, thank you guys so much for all of your questions. If you have time, we have time for a few more if you have them, but I'll just leave you with this note, which is that if you would like to download all of these results, they will be available on our website today, and I'll be sending out an email as a follow-up to all of you so that you have all of the information that we presented to you. And if you have any questions, feel free to reach out to Joel at Instrumental, Anna at Instrumental, Tobias at Instrumental, and we'll be happy to answer your questions. Thanks, guys.
Thanks, everyone.